Hi everyone, welcome to the F5OS learning. Let us continue with chapter 4, which is rSeries networking. In this chapter, we will deep dive into how networking layer works in F5OS. Part of this video, we will take a deep dive into F5OS in-band and out-of-band networks, explore F5OS port groups and pipeline groups, design our lab's physical and logical network connectivity, set up VLANs, create LAGs and assign VLANs to those LAGs. Alright, let us get started. From the previous videos, we all know F5OS is our platform OS. The platform layer F5OS supports two types of networking. The first type is the out-of-band network, which is used for the management plane. The second type is the in-band network, which is used for the data plane. Let us discuss about the out-of-band network. Out-of-band network is for management plan. The F5OS platform layer management plane is fully isolated from in-band data plane. This picture shows two colors, green for the management plan and purple for the data plan. I will simply put the management plane green is completely isolated from the data plane purple. F5OS out-of-band IP address is only accessible through the out-of-band management network. It cannot be accessed through in-band network. In fact, the F5OS layer does not have any in-band data plan IP address configured. rSeries tenants automatically inherit the management VLAN from the F5OS platform layer. Each tenant is assigned with a unique management IP address within the inherited VLAN. As shown in the diagram, the platform F5OS is connected to the management subnet, which is 10.10.5.0/24. The F5OS management IP address is configured as 10.10.5.15. Each tenant on the platform inherits the management VLAN and assigned an IP address within the 10.10.5.0/24 range. Let us discuss about the in-band network. In-band network is for the data plane. All the data plane networking is configured at the F5OS host layer. F5OS in rSeries uses link aggregation groups, which we call it as LAGs. VLANs are created and assigned to these LAGs. When the tenants created, they have assigned all the VLANs based on their specific requirements. Tenants in rSeries inherit only the VLANs they are explicitly permitted to access. In this example, tenant 1 inherits VLAN 230 and VLAN 231, which were permitted during the tenant deployment. Tenant 2 inherits VLAN 244 and VLAN 245, also permitted during the tenant deployment. Now, we have a clear understanding of F5OS in-band and out-of-band networks. Another important topic to discuss in rSeries networking is port group and pipeline group. To understand the port group, let us play a game. This game name is Birthday Cake Challenge. Imagine you are at a birthday party with 8 friends and you have got 100-gram cake to share. The game objective is to divide the cake fairly among your friends by following the game rules. Alright, what is the game rules? Let us first understand the game rules. I'm dividing the game rules into two parts. The first part is friends group rules. In this, your friends are divided into two groups. Friends 1 to 4 are part of group A. In this group A, each person can be served a maximum of 10 grams cake of each. You may skip serving any of them. If you serve to this group, you must serve an even number of friends like 2 or 4. Friends 5 to 8 are part of group B. In this group B, anyone can be served either 10 gram or 25 gram of cake. But if you serve one friend 25 gram of cake, all served friends in group B must get 25 gram. Also, if you serve one friend 10 gram of cake, all served friends must get 10 gram. This means you cannot mix 10 gram and 25 gram within this group. You may also skip serving any of them. If you serve this group, you must serve an even number of friends, like 2 or 4. The second part is cake cutting rules. The cake must be cut into no more than 8 pieces. Each piece must be exactly one of the two sizes, either 10 gram or 25 gram. You cannot serve less than 10 gram to anyone. You must serve a minimum of 80 gram from the total cake. The total cake served must not exceed 100 grams. It is okay to skip serving some of the friends. Alright, let us see the serving rule summary. Total pieces allowed maximum 8. Total serving sizes either 10 gram or 25 gram. Minimum total served at least 80 gram. Max total served not more than 100 gram. Per group serving should be in even numbers. Must serve 2 or 4 friends only. Group A limit only 10 gram allowed per person. Group B consistency, all must get either 10 gram or 25 gram, not both. Let us share the cake based on the game rules. Combination 1. We are sharing to everyone as the same size. In group A, all the 4 friends get 10 gram each. So the total is 40 gram. Also, in group B, all the 4 friends get 10 gram each. So the total is 40 gram. Together, the total cake used is 80 gram. This combination meets all the game rules, which is it uses minimum of required amount, which is 80 gram. It fits within 8 pieces. Also, it is not exceeding 100 gram. Combination 2. We are sharing to 6 of them with mixed size. In group A, all the 4 friends get 10 gram each. So the total is 40 gram. In group B, only 2 friends get 25 gram each. So the total is 50 gram. Together, the total cake is used 90 gram. This combination also meets all the game rules, which is it uses minimum required amount of 80 gram. It fits within 8 pieces. It is not exceeding 100 gram. Combination 3. We are sharing to 4 of them the maximum size. In group A, we are not serving to anyone. In group B, all the 4 friends get 25 gram each. So the total is 100 gram. This combination also meets all the game rules, which is it uses minimum required amount of 80 gram. It fits within 8 pieces. It is not exceeding 100 gram. Amazing! It was nice game. In this game, we made 3 combinations. Now, let us compare the cake sharing game to F5, PortGroup and pipeline group technology. First comparison. We should not exceed max bandwidth limit. The game rule says the total size must not exceed because the cake represents the available bandwidth capacity in F5. Just like in game, we must not exceed the total bandwidth. Second comparison. Different media types and port speeds. The friend groups are like different media types, each with their own maximum supported port speeds. Third comparison. The valid serving combinations in the game are similar to port group profiles in F5 rSeries. Let us have a look with an example to understand how this works. The rSeries 2800 hardware contains 4 × 1 bar 10 gig copper physical ports. Also, it contains 4 × 1 bar 10 bar 25 gig fiber physical ports. The rSeries 2800 appliances supports 3 port group profiles configuration. Profile 1 is 8 × 10 gig mode. Profile 2 is 4 × 10 gig plus 2 × 25 gig mode. Profile 3 is 4 × 25 gig mode. Alright, let us see these profiles in details. For example, if you choose profile 1, which is 8 × 10 gig mode, in this profile, ports 1 to 4, RJ45 ports, operate at 10 gig each. Also, ports 5 to 8 SFB ports operates at 10 gig each. The total bandwidth maximum 80 Gbps stays within the system limit of 100 Gbps. Important note: if you choose this profile, you cannot use 25 gig port at all. If you are choosing profile 2, which is 4 int 10 gig plus 2 int 25 gig mode, in this profile, ports 1 to 4 RJ45 ports operates at 10 gig speed each. Ports 5 and 6 SFB ports operates at 25 gig speed each. Ports 7 and 8 are disabled by the system. The total bandwidth 90 Gbps remains within the 100 Gbps system limit. Important note: if you choose this mode, you cannot use more than 4 10 gig ports. If you choose profile 3, which is 4 int 25 gig mode, in this mode, ports 1 to 4 RJ45 ports are disabled. Ports 5 to 8 SFB ports operates at 25 Gbps each. Only 4 SFB ports are active in this mode. The total bandwidth remains within the 100 Gbps system limit. Important note: if you choose this mode, you cannot use 10 gig ports at all. So, it is very important to choose the right port group profiles to get the correct number of 10 gig and 25 gig ports based on your needs. Alright, let us summarize what is port group. A port group is a way to set up and organize the physical ports on F5 rSeries platform. With a port group, possible of combination that tells the system which ports to use, what speed each port should run at, what type of cable or connector it uses, which ports are active or disabled. Also, while defining a port group, it is essential to ensure that the total configured bandwidth does not exceed the device capacity. You can apply one port group profile to a pipeline group at a time. When a new port group profile applied to a pipeline group, the device reboots to reconfigure the ports, interface speeds and modes accordingly. Alright, we saw something. A port group profile is applied to a pipeline group. Okay, what is a pipeline group then? Playing the game with one cake is like using one pipeline in F5 rSeries. Each pipeline supports a max bandwidth of 100 Gbps. All port group rules apply within that single pipeline. Using two cakes in the game is like using pipeline 1 and pipeline 2 under a single pipeline group in F5 rSeries. In F5 rSeries, a pipeline group can contain maximum of 2 pipelines. Every F5 rSeries device must have at least one pipeline. A pipeline group contains 2 pipelines, each capable of 100 Gbps limit. The maximum number of pipeline groups depends on the F5 rSeries hardware model. For example, the F5 or 10,000 series supports 2 pipeline groups, totaling of 4 pipelines. Alright, why F5 rSeries dividing the hardware using pipeline technology? Great question. Let us see it with example. Your organization purchased a new rSeries 5800 appliance and your organization want to use the same hardware for both data center and DMZ networks while keeping them fully isolated in hardware level. Is it possible to achieve without buying a new hardware? Yes, using F5 rSeries pipeline technology. Pipeline in F5 rSeries appliances provides physical hardware level isolation by dividing the internal architecture into separate data processing pipelines, each with dedicated resource like CPU cores, network interface queues, memory access pods. We will discuss how we can achieve our requirement. The F5 rSeries 5800 appliance supports 2 pipelines with a single pipeline group. This enables isolated hardware level traffic handling. In this setup, pipeline 1 is assigned to the data center. Port group 1 maps ports 1 and 3 through 6 to this pipeline. Pipeline 2 is assigned to the DMZ. Port group 1 maps ports 2 and 7 through 10 to this pipeline. This configuration provides strict hardware-based separation between the DC and DMZ environments, which is enhancing both security and performance. In F5 or 5800 series, you might see an oversubscription warning. They gave you 2 choices in pipeline 1. That is, use port number 1 as 100 gig speed or use port numbers 3 to 6 as 25 gig speed each. This way we won't end up with oversubscription. Also, they gave you 2 choices in pipeline 2. Use port number 2 as 100 gig speed or use port numbers 7 to 10 as 25 gig each. This way we won't end up with oversubscription. Important point to note here is do not use 100 gig as well as all the 25 gig together. F5OS pipeline technology. What you should know prior to start. The R2000 and R4000 models support only a single pipeline. So, you cannot do hardware level separation using the lower end models like R2000 and R4000. Higher end models support 2 pipelines with a pipeline group. When creating a LAG, all member ports must belong to the same pipeline within the pipeline group. This is because the ports are physically tied up to a specific pipeline. In this example, there are 2 pipelines. Ports 3 to 6 tied up with pipeline 1. This we call it as red pipeline. Ports 7 to 10 tied up with pipeline 2, which we call it as green pipeline. You can form a LAG within the red pipeline or within the green pipeline. However, you cannot create a LAG between the red and green pipeline because they are separated using pipeline technology. Now, we have a clear understanding of F5OS port group and pipeline group. Alright, let us design our lab network. We have two rSeries 2800 hardware. We name it as F5 host1 lab.ae and F5 host2 lab.ae. We have configured with the management IPS 10.10.5.15 for host 1 and 10.10.5.16 for host 2. We used the 8 and 10 gig port group profile, which allows each port function at 10 Gbps speed. We also choose to set up two LAGs, one for the data and other for the HA. The data LAG ports are 1 and 2. The HA LAG ports are 3 and 4. The data LAG ports 1 and 2 are linked to the network switch port 1/0/1 and 1/0/2. The HA LAG ports 3 and 4 are interconnected. Part of our lab network design, we are going to complete 3 tasks. Task 1. We need to set up data VLAN's LAG on both rSeries 2800 devices. Task 2. Also, we need to set up HALAG on both rSeries 2800 devices. Task 3. We need to create the VLANs and assign them with the appropriate LAG. Alright, let us discuss all the 3 tasks in more detail. Task 1. We need to set up the data VLAN LAG on both the rSeries 2800 devices. Port 1 and 2 used for in-band data LAG uplinks. We have connected port 1 and 2 to the network switch. On the network switch side, dynamic LAG is configured. Also, physical port status came up on the switch side. However, LAG status is showing down because in rSeries side, we have to configure the dynamic LAG. Also, we have to verify the port physical status and LAG status. Task 2. We need to set up the HA VLAN LAG on both rSeries 2800 devices. Port 3 and 4 used for in-band HA VLAN LAG. We have connected port 3 and 4 between F5 host 1 and F5 host 2. Now, we have to log into rSeries host 1 and host 2 and configure the HA VLAN LAG, verify the physical port status, and verify the LAG status. Task 3. We need to create the VLANs and assign them with the appropriate LAG. For the deployment of tenant 1, we required 3 VLANs. VLAN 230 for publishing, which we call it as client-side VLAN. VLAN 231 for reverse proxy, which we call it as server-side VLAN. VLAN 4001 for high availability. It is necessary to create these VLANs and associate them with the appropriate LAG. In our lab, VLAN 230 and VLAN 231 should be assigned to data LAG. VLAN 4001 should be assigned to HALAG. We will complete all the 3 tasks at section 4. Let us proceed with creating the data and HALAGs, creating VLANs for the data and HALAGs, assign the appropriate data and HA VLANs to their respective LAGs. Log into F5 host 1 and host 2. Let us check the interface status on host 1. Data LAG ports 1 and 2 are up. Also HA LAG ports 3 and 4 are up. Let us check the interface status on host 2. Same here. Let us check the configured port group on host 2. 8 and 10 gig port group profile applied. In this profile, all ports operate at 10 gig speed. Let us check the configured port group on host 1. Same here. Let us check the physical interface LACP status on host 1. Interfaces 1 to 4 are up. LACP is in default state. Also, no LAG has been configured so far. Let us check the physical interface LACP status on host 2. Same here. Also, no LAG has been configured so far. Let us configure the data LAG on host 1. Go to LAG and click Add LAG. Enter the name as data LAG. Set LAG type as LACP for dynamic LAG. Add 1 and 2 as configured port members. Click Save and Close. Let us wait for few seconds for the LAG to negotiate and come up. LACP is now up on host 1 with an aggregated bandwidth of 2 Gbps. Let us configure the data LAG on host 2. Go to LAG and click Add LAG. Enter the name as data LAG. Add port 1 and 2 as configured members. Set the LAG type as LACP for dynamic LAG. Click Save and Close. Let us wait for few seconds for LAG to negotiate and come up. LACP is now up on host 2 with an aggregated bandwidth of 2 Gbps. Click LACP details for advanced view. You could check LACP details on host 1 as well. Alright, we are done with the data LAG. Let us configure the HA LAG. On host 1, go to LAG and click add LAG. Enter the name as HA LAG. Set the LAG type as LACP for dynamic LAG. Add port 3 and 4 as configured members. Click Save and Close. Please note, this is HA LAG. The LAG will not come up until the peer configuration is completed. So, let us go and configure the peer. On host 2, go to LAG and click add LAG and enter the name as HA LAG. Set the LAG type as LACP for dynamic LAG. Select port 3 and 4 as configured members. Click Save and Close. Both the side LAG is configured. Let us wait for few seconds for LAG to negotiate and come up. HA LAG is now up on host 1 and host 2 with an aggregated bandwidth of 20 Gbps. Let us check the HA LAG status on host 1. Alright, we are done with the HA LAG. Let us configure the VLAN on host 1. Go to VLAN and click add VLAN. Type VLAN ID as 230 and type VLAN name as bub. Click Save and create another to repeat because we are going to create more VLANs. For the next VLAN, type VLAN ID as 231 and name as RP. Click Save and create another to repeat. Next VLAN ID is 4001 and the VLAN name is HA. Click Save and Close. Data and HA VLANs are configured. To add data VLANs to data LAG, click Edit Data LAG and select VLAN 230 and 231. Then save and close. To add HA VLAN to HA LAG, click Edit HA LAG. Select VLAN 4001 and click Save and Close. We have assigned data and HA VLANs to appropriate LAGs. We are done with host 1. Let us configure the VLANs on host 2. On host 2, go to VLAN and click Add VLAN. Type VLAN ID as 230 and VLAN name as bub. Click Save and create another. The next VLAN ID as 231. Name as RP. Click Save and create another. The next VLAN ID is 4001. Name as HA. Click Save and Close. We have created data and HA VLANs. Now we have to add data and HA VLANs to appropriate LAGs. To add HA VLAN, edit HA LAG and select VLAN 4001. Then click Save and Close. To add data VLANs, click Edit Data LAG and select VLAN 230 and 231 and click Save and Close. Data and HA VLANs are assigned to appropriate LAGs. We are done with host 2. We created the data and HA LAGs. Also, we have configured the VLANs for data and HA, and we assigned the appropriate VLANs to their respective LAGs. Great. We just took a deep dive into how networking layer works in rSeries platform. We also set up the physical and logical connectivity for our lab.ae network. This includes the management, data and HA networks. Alright, we are done with chapter 4. Please continue watching the next video, which is Tenant OS deployment preparation. Thank you.